All right, let's do some classwork on multiple regression. We are going to use an Excel file that I've provided you called ELS example. And when we open the Excel file, as you'll see here, we have a variable called race ethnicity. And in this data set, 1 represents white, 2 black, 3 Hispanic, and 4 other races or ethnicities. And so what we want to do here is create some dummy variables we want to create 3 dummy variables using if statements for the other 3 categories, black, Hispanic, and other. White represents the majority in this data set, so we're going to use that as the referent group. All right, so we will create our variables, name them. All right, and I need to write my if statements. So I'm going to say equals if race equals 2, then the value's true, otherwise false. And so we see here for this first student, their race is Caucasian, and so we get a 0. All right, we'll do the same thing for Hispanic, equals if race equals a 3, then that will be our true, otherwise false. And so again, we see for this first student who's Caucasian, we get a 0 for Hispanic. And then for other equals if race equals a 4, that is now our true, otherwise false. All right, and I can highlight all 3 and double click, and I see, let me take a look here at example row 5. We see here the student is Hispanic or black, and so we get a 1 in the black indicator variable. And then this student is another race or ethnicity in row 3, and so in the other indicator variable we see a 1. All right, and so this is an Excel file that we are going to want to load into JASP. So I need to save it as a CSV. So I'm going to go to File, Save As. And I'm going to name this ELS example classwork. And I'm going to save it on my desktop. And I need to save this as a comma separated. By default, I tend to choose the MS-DOS comma separated. Again, you can choose just the regular comma separated. Just stay away from Macintosh if you are on an Apple. All right, so I've saved the file and I can close the Excel file. And now I can go to JASP and open our new CSV file. All right, and we can scroll over and we see our 3 indicator variables that we created. All right, so let's go to problem 2. With your new data file, run a multiple regression of instrumental motivation and English self-efficacy on standardized reading achievement. Okay, so we're going to go to regression. All right, and we want to run instrumental motivation as a covariate and English self-efficacy. And our dependent variable is reading achievement. And recall, we need to go into statistics and choose collinearity diagnostics, everything under residuals, and then in our plots, residuals versus predicted and QQ. Okay, and our first question here is interpret the adjusted R squared for the model. All right, so I look at my first table and I see the adjusted R squared of 0.119. So that tells me that 11.9% of the variation in reading achievement is explained by instrumental motivation and English self-efficacy. All right. Are the residuals correlated? How do you know? All right. I can look at Durbin-Watson, and for my alternative model, I see a statistic of 1.589. That value is between 1 and 3. And so, yes, we can assume that the residuals are independent and are not correlated. What is the omnibus p-value, and what does it tell us? All right, our omnibus p-value is in the ANOVA table. It's next to the F statistic. It tells us that in this model, that at least one between instrumental motivation and English self-efficacy explains a significant amount of the variation in reading achievement. So at least one of them does a good job. Is the assumption of no multicollinearity satisfied? How do you know? All right, we can go down to our coefficients table and look at our tolerance and variance inflation factor. All right, and we see that the tolerance is for both of our independent variables is greater than 0.2, and the VIF is less than 5. So we can conclude there is no multicollinearity. All right, E. How many potential outliers do we have, and should we be concerned? All right, let's scroll down to our case-wise diagnostics. And we see here, let's see, we've got 2, 4, 6, 8, 10, 12. 12 possible outliers. But again, keep in mind in this data set that we have thousands of students. And so 12 possible outliers is not a concern. We can just continue working. All right, F, has the assumption of homoscedasticity been violated? All right, that's our residuals versus predicted plot. We're looking for random scatter, and we do see random scatter around the baseline. We do not see a pattern, and so we can assume homoscedasticity in our errors. Have the assumptions of normality and linearity been violated? All right, this is where we look at our QQ plot. And we see slight deviation at the very end, but by and large, the standardized residuals fit along the diagonal, and so we can move forward with our normality and linearity assumptions. All right, write the regression equation using unstandardized values. All right, let's go back to our coefficients table. All right, and I'm going to type this out for you. We need to insert all right, so we have reading achievement equals our intercept 51.716 plus 1.78 times instrumental motivation plus 1.986 times English self-efficacy. All right, and that is our regression equation. What is the effect size of English self-efficacy on reading achievement? So here I look at the standardized coefficient for English self-efficacy, and I see that it's 0.2. Recall 0.1 is small, 0.3 is medium, so this is a small to medium effect. So again, English self-efficacy has a small to medium effect on reading achievement. All right, let's rerun our multiple regression with the race, ethnicity, and dummy variables. Research suggests that parental aspirations for their children have a strong association with achievement. As such, we also want to control for parental aspirations. All right, so we want to go back up here. And parental aspirations is ordinal, I believe, on a 7-point scale in terms of how far they aspire for their children to go in school, from do not graduate high school all the way through doctorates. So we'll put that in covariate, and we'll add our race indicator variables as factors. All right, and as that is running, we see that our first question here is interpret the adjusted R-squared for the model. So we go all the way back up to the top. And actually, but do we, hold on, I ask about outliers, but let's just do a quick check on our assumptions because we did add two variables here. So our Durbin-Watson statistic is still fine. It's between 1 and 3. Our tolerance and VIF both are above 0.2 and less than 5. We've got random scatter along the baseline. And we have good fit of the standardized residuals on the diagonal. So it doesn't look like any of our assumptions changed. We do see, and I believe this is question B, how many potential outliers do we have and should we be concerned? We do see that we've picked up a few more outliers, but even here, let's see, 2, 4, 6, 8. So we got 32 potential outliers, but keep in mind we still have thousands of students, and so 32 is not something we necessarily need to be concerned with. All right, so question A asks us to interpret the adjusted R-squared. So our adjusted R-squared is 0.251. So 25.1% of the variation in reading achievement can be explained by instrumental motivation, English self-efficacy, parental aspirations, and race ethnicity. All right, we want to write the regression equation using our unstandardized values for the coefficients. All right, so I'm going to go to insert and insert an equation. All right, so let's go to our coefficients table. And we have reading achievement equals our intercept 43.915 plus 1.401 times instrumental motivation plus 1.787 times English self-efficacy plus 1.822 times parental aspirations minus 8.488 times Black minus 6.548 times Hispanic minus 2.457 times other. Okay, and so here we see our regression equation. All right. When controlling for parental aspirations, what happens to the effect size of English self-efficacy on reading achievement? So recall before the standardized coefficient for English self-efficacy was 0.2, and here once we added parental aspirations, which has an effect of 0.23, we see that English self-efficacy decreases a little bit to 0.18. So now it's a little bit closer to being a small effect, and we see the bigger effect of parental aspirations. All right, if a Hispanic student has average English self-efficacy, and remember these are standardized, mean-centered, average instrumental motivation, and average parental aspirations, and the average parental aspirations is 5, which represents graduating with a bachelor's degree. What is their predicted reading achievement? And so we would have that their reading achievement is equal to 43.915, all right, plus 0 for the instrumental motivation, because it is average, plus 0 for the English self-efficacy, all right, plus, and here we would want to do 1.822 times 5 for the parental aspirations. All right. And this is for a Hispanic student, so minus 6.548 because we're multiplying times 1 for Hispanic. Okay, and so I am going to go back to my favorite calculator, Excel. All right, and so we can do this equals 43.915 plus 1.822 times 5 minus 6.548, and I don't need to times 1. All right, and so we get here, all right, a predicted reading achievement of 46.477. All right, and at this point, you should be ready for the homework.